Um, all right, let's just go down the list.
Yeah, let's do that. And if you need to go somewhere else from where you are, just go to it.
Okay,
And make sure to speak clearly.
okay.
Oh, yeah, by the way, hello, Professor. This is our group project for CMP428 video game programming. This group involves Jonathan Cruz, right? Jonathan Cruz.
What's- John Cruz is going on.
Daniel Weiner, Andrew, I don't know his last name, and Luis, I don't know his last name. We'll get their last names for you in the email. What we did was a Pokemon basic emulator from like the Game Boy Colors, like Pokemon Yellow, Pokemon Red, games that we used to play when we were kids. So I'm gonna let Jonathan start with. We're just gonna go straight down the list of our classes.
All right, we'll start with animation. Animation was one where we went through each files structured based on their file. They had to be structured a specific way with their name, their animation, and we just gave it a number. That way it could follow and automatically reset, and we'll see later on what was doing the magic under that. Um, Dan, if you want to speak about your assets.
Asset is just a an interface that was used by a couple of my classes, which you'll see later on. It was just something that made a lot of things very easier down the road. You keep going. Oh, okay. So A star node was used in conjunction with a lot of stuff. So I had this is kind of a group of classes that all work together here. So A star node is actually an abstract class that worked with a couple of classes. Subnode, A star search, game state, player trainer, enemy, entity. So these all work together, and we'll go through them later. But these all work together to choose attacks. It is the AI, the enemy AI, the battle AI. So basically, it's just a simple A star search based on the state of the game. So I researched game states, like how chess game states and Connect Four game states, tic tac toe game states, and like what you can do with them. So I made a simple graph idea of what a Pokemon game state would look like and what the variables would be for that. I made classes that represented that, and I made an A star search, A star node, A star search class to search through that. So the A star search class actually does the search. It uses a priority a priority list, which is just a linked list, and it just does an A star search, which I got. I got a lot of help from the book with that. Game state represents the game state. So what that takes in is a player trainer, which represents the trainer, which is the actual player. It's called enemy because the enemy class, which is the AI, is considered the self in this situation. So the variables are the reserve Pokemon that each person has, the Pokemon health that each Pokemon has, the Pokemon type that each Pokemon has, and the Pokemon level that each Pokemon has. And so basically, what I had was a static int that I used as an index that went into the attack list of the Pokemon. So the A star search returned a list of integers that would be that represented the attacks that you should use to get to the end state of basically having no Pokemon left and no Pokemon health left for the player trainer. It's just basically beat the Pokemon, beat the player trainer for you, and it also used different levels of consideration based on the skill level that you passed in. So there was a lot that went into it, and I'll go into more of that once we get down to subnode, which is way towards the end. But we'll keep going for now.
Okay. Attack was just something we inherited from stats. Every Pokemon they had certain stats, and these stats helped us derive how much would an attack be, how effective would it be for what kind of Pokemon. And if we go down to stats, we could really see the bones of what these functions does for defense, attack, speed, special attack, special defense, and HP. So a lot of this we had modifiers. Modifiers is between battles how your defense and your attack and certain stats could shift based on what kind of attacks Pokemon did. We lightly implemented, not so much because there wasn't so much time. However, based on your level, these would increment or decrement, and these were all calculated. And then IB, it's something that even though you have the same Pokemon, you see here that super rare, rare, and common, certain Pokemons would have higher IB in their stats, and they would be different because this is randomly generated. But you have a higher possibility of having higher IBs, which accumulate when you get to level 100 because it is cumulative based on your level. And the magnitude is just the magnitude that we each Pokemon have, and these are just the formula that are sort of involved with the weights between damage and attack, just to bring a consistent value based on stats and how they're shifted. But this stats section basically covers all of attack, defense. We have special attack, and HP is just slightly different. HP, we had to bring certain functionality because HP, it's sort of you have to see it as that's the main stuff you see when you're in battle. The HP goes down and up, and where you're at. So that's something you constantly have to know. So we had to add a few extra methods, and then the magnitude was calculated slightly different, and the way we calculated the magnitude was uh, you have this plus 10, and then yeah, it's just a plus 10, the difference from there. And from there we move on to attack listener, which when you're in battle and you're in attack, so this is basically just grabs our events. What are we doing? And here's
The sound
shout out to
manager.
Lewis for the sound manager that he gave us. uh so the sound manager basically plays these sounds as we're following the actions, and when we perform these actions, you could see this is special thanks to Dan. He gave us this. He beautifully managed to give us a class of enemies and trainer player that basically allowed us to get every value that we needed within the battle without having to extremely code or hard code anything. It was pretty amazing. And we moved to the battle UI frame. This is a shout out to Andrew, which he essentially gave us a battle screen. So basically, this is just the outside. We'll see later as it's visual. So this comes. We sort of all worked on it. Andrew gave us basically the layout for the battle UI Pokemon and the battle screen, and with this layout, it basically made it easy for us to understand what we have to do. And this, like us, a lot of this is visual, but it does calculate HP, which is why HP needed some extra methods,
You just had to
which is
add
part of stats.
functionality.
Sorry, was that
Sorry, you just had to add functionality and connect it to the game.
right? Uh, and here we have our battle screens, and we which again Andrew wrote. The and we had to add functionality, and as you see, it works with conjunction in the game with all these variables, and they add all these variables basically helps us determine whether are we going to attack, are we switching Pokemon, and if the attack is performing. We want to make sure that we have loop counters, and these counters let us know how we could proceed through the attack, because when you print a string as a text update, it's being called at 1/60th of a second, but you don't want to display for 1/60th of a second. So you want to allow time for it to show on the screen and really give the user time to understand when he's being attacked, what kind of attack. and when he's gonna attack, what did he perform? And battle box, that's sort of just something very visual, which we'll see, and uh, this just lays out and displays our battle box, which would be after we choose to attack. It'll list our attacks, and it this heavily relies on Dan's player trainer class, which made it all much easier in the world. And let's see, battle key listener is just another listener. Sort of, this was given to us by Dan, and it helped us implement and facilitate the battle. Then we have battle manager, which me and Dan worked on this. And as we can see, again, it heavily relies on the player trainer and enemy class, which Dan wrote, which is a common thing in this project. So we'll see that we just collect all this, and these things, they actually rely a lot on HTTP request as well, and we sort of had to prematurely add these in the game while we're playing it on a different thread, and that's what we'll see next. We had to do that because the HTTP request, not only if the internet was slow or whatever, we had this on a separate thread, and it just had five backups just in case if we didn't have any. And whenever it drops below five, it'll automatically say, "Oh, okay, this is no longer less than all right, this is less than five. Now let's run this loop." And we have box, which this essentially, it's all the math here is essentially contained on how we have our enemies walking, our physical enemies, and detecting. So we have two enemies class, and those enemy then basically develop the enemy that's within battle, and I developed the physical enemy. And this is just taking a portion of the map, so we see where there's confrontational grounds, and confrontational grounds just means you could find a fight in Pokemon. And so we have these confront instance, which they're confrontational tiles, and if we're there, it allows us to detect about, I believe it was 6 or 9 points within each tile, and each tile is that point is chosen randomly. So the enemy is gonna walk to that tile. So each of them would have a box, and within that box, they'll walk to a tile consistently,
I think you made
switching
it 9.
actions.
I think you made it 9 points.
Huh?
I think you made it 9 points. Sorry, keep going.
Oh, it was 9 points.
I think you said it was 9 points. Keep going
Okay.
though.
Yeah. It's been a while.
Yeah, that was way back at the beginning.
Camera. This camera was actually, it has some neat work actually. We had a problem when we were getting towards the end that you started to see outside the map and you started seeing the white background. So we gave it this little power switch. So we just turned it off when you got to the end of the map. If mathematically the bounds half of the screen was, if you was approaching, if you was in the middle and halfway through there, that already reaches the end of the screen. So just turn off because essentially you're not going to see much. You're going to see what's out there, and that's what we did for. And then character again, which is the physical version of Dance player trainer, which this is just the guy walking, and here he did have some jump functionality, but we didn't need it. And Here, this is just so he could run, pressing the shift key, he could move. And I had to speed it up after I added another thread because he'd slowed down. Um, and Here, we expand array in case if his animations increased. This add list, basically, you use it for any character, and it's basically to add animations, but this had to be preloaded in the main method. Um, and get action image was basically to determine his next action, and perform action image is to perform the action that he just got. Um, collect. Oh,
Collectible object is an abstract class that implements asset. It was just a basic abstract class that could be inherited by all the collectible objects, which just managed to be two things: money and a super potion. For anybody who's ever played one of these Pokemon games, you know what a super potion is. So those were implemented. This is just all the information that it could possibly be. We did talk about implementing dropping it in the world. It does have the functionality. We just didn't draw it. But besides that, I mean, because it has the image, it has the location. We just literally just didn't draw it in the world. But it can go into your bag. It can be removed from your bag. It can be put in the world. It's got a value that you can buy it for, which is less than the value, which is more than the value you sell it for. It's got a strength, which is how much you can, how much it heals your. Well, it's got a strength, which is how much it does. Well, that's actually the super potion itself. Just this abstract class has a little bit less than that, but it's got a description and all that. But yeah, you can keep it going.
Common. That's one of the inherited classes from Pokemon, which we'll just get to Pokemon. But here with common, you also have rare and super rare, which we all came to the consensus of this idea of a Pokemon. You have three types of Pokemons, and those three types of Pokemons, you want to determine how strong they are based on that. And here's the Pokemon class, which it's pretty extensive.
Yeah, it is.
And this heavily relies on HTTP requests from the Pokemon DB database, and because it would be a lot of tedious work having to get that. But here we have on our attack list, and this is where Dan's player trainer used it to perfection. We had here's the stats we discussed earlier, and then the level that determine the stats after you calculate the magnitude. Um, Here, these are just the types. We had to create a hash map from one beginning, and it has to be preloaded. Uh, this was pretty excessive calculation, but when you attack, these are taken into consideration. Um, and these are just weights to how strong the values are, and we just loaded them, and then this just loads the inner types, which is just you can see the function call here, and it's just calling these, and these are just type of. They just contain the final. These things are just final strings. That way it was easier just to name them. Set types, that gives you your type. This is based on HTTP requests, which we'll probably um, see later. And then gather experience. We were planning on doing this where each Pokemon would gather the experience from the Pokemon they just beat. There wasn't much time to implement it, but it was spoken about. Calculate level is just every level, so 1.25. So the experience required to level up would just be 1.25. So if you want to be level 50, you would have 1.25 to the power 50. So it would it would get harder to level up each level because you're going from 1.25 to level 2, right? But then 1.25 to the third level is much higher, and then 1.25 to the 10th power is much higher, much more experience. So that's that's exactly what it sounds. Get attack data. This again, this was a HTTP request, which we'll see later, and does learn, not implemented in the game. We just managed a way to generate an attack list. Because there wasn't much time, but generated attack list is pretty amazing, and it does do a lot of what I feel trainers would choose for their Pokemons to have. Um, and then learn attack. That's another stuff where we was thinking about it. And then we have this generate map for attacks, and this map is just so every attack could map to a specific attack, and it could use the weakness types in order to determine. And this is used in calculate damage, as you can see. Um, with that, this had a lot of the magic behind how we're gonna calculate the damage. And as you can see, it has a lot of math here, and basically this math, um, this is what decides what damage is going to use, and it was used extensively. And then A is weak against
That was
this specific.
used that was used for my AI. I asked for that specifically, and it was very useful to get comparisons done for the A star search to be able to check which Pokemon was strong against other Pokemon when the AI was picking which Pokemon to switch to, which Pokemon would be best to beat the player's Pokemon.
Okay, and confrontational dot Java. These are just tiles. They extend from a tile class, which we'll probably see later. Uh, and these is where you see the Pokemons, and when you encounter them, wild Pokemons. And then you have confront. Uh, Confronts. This is the user. This is the UI for when a Pokemon is constructed, and it just makes sure to change the state. So it gives you a little visual and be like, oh hey, this is happening, and then defense is one of those stats that was inherited. Enemies, then I'll talk to you about. This is one of the legendary classes I was talking about.
Oh, this is
No, this is
yours.
mine
This is
actually.
yours.
Uh,
The
this is the
next one's
physical
mine.
guy. Sorry, this is the physical guy. These are the guys you'll probably see with them walking around. They're just moving and looking, just random guys in the grass looking around, and I guess they just want to battle you. And they use the box here. They each have their own box, how I explained earlier, and their actions, as you can see, this is what determines where they're gonna move or not. And they use hash maps, and then we evaluate their decision every so we see here generate actions, but as you can see here we have a specific, where is it, um let's see, so we have these unreachable ASCIIs just to know which way he's going, and I call it unreachable ASCIIs because I don't want to confuse it with ASCII commands because you have to pass them in. And you have the enemy loop, which enemy loops extend every single time. And then here we have action change bound. So this is just indicating to us when we want it to change. So enemy loop reaches action change bound, and you'll see that once it reaches there somewhere here, will if action change bound is ready, then this is where we make all the decisions on where would the enemy change directions, and uh according to the camera and all that good stuff with them. And now we're in the legendary class.
Yeah, you'll see why we got confused here because enemy and enemies, we didn't talk about the names apparently. So the thing is here, this is the information that makes up a character, and you'll see the next class, which this is inherited from, called Entity. So this one has a skill level and a bag. Well, the bag is just his inventory, but his skill level, which is what I talked about earlier, which basically makes up what he uses, how many decisions he uses. So it goes from 0 to 3. So there's 4 skill levels. 0 is a wild Pokemon, randomly picks an attack to hit you with, and 3 is the highly skilled trainer, and he uses every single bit of information at his disposal to make an attack. So he'll take into consideration your Pokemon's type versus his Pokemon's type, your Pokemon's level versus his Pokemon's level, how many reserve Pokemon he has and how many reserve Pokemon you have, your Pokemon's health and his Pokemon's health. He'll take everything into consideration before he makes an attack, and then he'll finally do it. So we have some functions here. I do want to give Jonathan his due. He keeps shouting me out for my classes, but he also did some great work here that made my stuff much easier and much better. So enemy switch, he helped me out with that. It was just made my stuff work with the battle UI screen and the received damage stuff. You could just set inventory. Entity is more interesting than this. Let's go to entity, and I'll talk about that. So this one has a name, inventory size, bag, money, which is the amount of money he can carry, and that was meant to be. We never implemented this, but like when you defeat an enemy, you would gain a certain amount of money, just like they do in the game, and that would be the amount of money. And also, I implemented some merchants. You'll see later. They would have money, so they could trade and stuff. Reserve Pokemon, total Pokemon. That's all, and also the Pokemon array. That's how their actual Pokemon are kept there. And then Poke Health is just the current Pokemon's health kept as a percentage. So basically, all this stuff is just a representation of their information. They're constructed with a list of random Pokemon, and this is Jonathan's really great work right here. His HTTP request. You see, he passed in Route 1. That's actually one of the areas in the game. So Route 1 actually generates Pokemon from that area in the game. So you could change that, and so Route 1 is one of the earlier areas in the game, so you get very low level Pokemon. But if you changed it to like Route 28, it would be one of the last places in the game, and they'd be very high level Pokemon. So you can set the area to be like an area in the game. It's really awesome. And then everything else is just like accessors, and like change your current Pokemon, get your current Pokemon, get the HP, change the Pokemon health, get the attack damage, draw, stuff like that. It's pretty straightforward. You can go ahead. Where did I drop my pen?
File action. So file action is the magic behind animation. This breaks it apart, and this tells us how much each pictures how much animation pictures does each naming convention has. And then I guess since we're here, shout out to Matthew Johnson, and this is, I don't know how I got here, but there it is. Floor. This is this is something I don't think I implemented. I think I actually called it tile. This was originally what was going to be mapper, but then frame practice. This was all about deriving the graphics and getting the screen width and all of that good stuff. And then we have Game Man, which everybody asks me why I call it Game Man,
And
and
he doesn't remember.
my famous response is I'm not too sure either. Uh, and So we have here a few game-based game modes that actually helps us determine what is it that we're gonna draw, and that's how we switch between screens, between battle screens, between menu screens, between um, confrontation screens, and then this this screen adder is just an abstract method in game base that helps us determine exactly where what kind of listener are we using. Uh, and then game base, as you can see, I think I stole this from Dr. Murphy himself. So shout out to Dr. Murphy, I guess. He's uh, let's see, and then we have add character, which you could just call this, and it'll add the character, and it'll set a specific counter by itself. You could add enemies. It's gonna add it to the same list, but we just did that so we could redraw them as long as they're in the list. And here we have some abstract methods, which is the paint. Well, this is a paint method, but we have the panel paint, which this extends this paint if you want to draw anything extra, or you have inner run if you want to run anything inside the first thread if it's not there, and this key press. This also has a screen adder, which if you want to add any extra listeners. In game state here, then was talking about it.
Game
HP.
state, yeah. Game state is just the physical the representation of what the game could possibly be at any given time. It's just you can see what the enemy Pokemon type and enemy Pokemon health is, and your Pokemon type and your Pokemon health is. That's all it is.
Then we have HP. I discovered. I discussed it on the stats. Um, image layer. This also has to do with actually no, this one no, and mapper. This is Mapper, which I feel like it's a pretty powerful class. This essentially calculates the screen based on how many tiles you give it, and this pig to character ratio is how big you want the character be according to every picture, and then fits a screen is how many squares do you want to put in the screen, and they're actually squared. So if you want 5 by 5, 6 by 6. And it would just map everything, and you could give it a text string, which is right here, and this essentially defines the map. So it reads this is use 3 letters to read the image, and then it'll use um, one of these flags here to determine if it's unwalkable, if it's walkable, or if it's confrontational. And those are just all tiles, but it uses those letters to determine that. And as you can see, there's a lot of math. First, it moves it to the middle, and it determines what would be the bounds, because from the middle, it want to have equal side on the left and equal side on the right. And that's where you get a horizontal bounds, your vertical bounds, and it'll load your map squares, which those are the independent tiles. And which helps a lot when we go into a battle. We could redraw the screen because we just have to load the map square again. And because we did do some animation, and then get character location. It helps us understand where the character is, and that way we can know who's confronting him with the enemies. Uh, Menu box column. Um, this I don't believe it was a box I finished, but we have menu key listener, which will have a menu and we'll display it. We have a menu screen, which again will display it, but this has a lot of math too, where it's pretty abstract. You could give it how many columns you want, and yeah, you'll say the number of boxes, and it'll give you 3 for each. The idea was to have 2, and then it'll provide 3. Uh, but now you want to talk about merchant?
Oh, Merchant is just an NPC. I just hard coded some super potions into his uh, bag. He extends entity, so he basically has all the properties of any entity, and he can sell you items. If you instantiate him, he can sell you items. That's all. Money is the actual money. It's a collectible object, so it can be found on the ground. It's got a description. You basically just put the owner into the constructor, so you could drop it. It's got a sound when you pick it up, and you could use it to buy and sell things with the merchant if that's constructed. That's done. And then obviously extends collectible object, and that extends asset. More math was just something that I used with A star. It's just for comparisons. It's just some more code that I needed from the book. The book helped me out with this. Because A star was actually a pretty complicated algorithm. So these are just some utility functions that aren't available through Java. Okay.
Not enough tiles is just and here is an exception. I wanted to make sure that it raises an error if you put too much tiles. I don't know to what extent I was going to use the mapper class. And here's another legendary class.
Player trainer extends entity. He's got this is the actual trainer's information. He's got a bag. He's got his Pokemon list. It's everything not physical about the player trainer's class. We just physically coded some Pokemon in just for the testing. We can make that random if we wanted. Yeah, and he just has all the things that an entity has. So anything you could do with an entity, you could do with him because he extends that class. So he's pretty useful because you could use him with the A star. You could access him anywhere. You could use him with the enemies. So Jonathan found him pretty useful, and I'm glad about that.
Pokemon, we discussed it. Let's talk about um, Pokemon box. It's just literally a Pokemon box. It just show us Pokemons when we want to switch. It's a UI. We'll see it. We have Pokemon List. Pokemon List. This was just how to generate random Pokemon list. This was the idea behind it, and we used to fill randomly because we'll see it in the next class where we'll use some of the HTTP requests to get these random Pokemons, and yeah, they just have number of Pokemons, and max Pokemon obviously is six. If for whoever's seen Pokemon, and then random Pokemon generator. This is where we just pass a location, and then the location will basically make a HTTP request to the database of the Pokemon DB website, and then from that website, it tells us the Pokemon. It'll parse the levels, and then it'll generate them. Um, and then rare, it's inherited right from Pokemon. Uh, right. I think everybody's computer gaming class seen this class many times. Uh, request.info. Um, Here we go. We just parsed the HTTP request. Um, we just this set get. That's what the mainly I use that to parse the main request. And when I call it, I'll just add something here because it has a parameter Pokemon, and then it'll get it for us. And I'll just use these loops kind of to parse them. So here's to get the base stats, which Pokemon does it. Here you'll get the which one is this one? Type. This is usually what helps us get the type, which was the easiest one out of all these requests to parse. This one, Pokedex Pokemon. This actually helps us get all the attacks for a specific Pokemon. And this one allows us to get all the attacks, and that's where we generated the map. And then we have a list of Pheromones in area, which basically gives us the based on their location is what was used to find them. And nothing much said. Again, all of them is they just loop, and you just keep on changing variables to go through the HTML and actually parsing through each one of them. It looks messy. Not sure if there's a clean way to do it, but I just think dealing with HTML is messy. So um, I guess a spade for a spade. That's how they say it. Uh, Rows and columns. You know. So yeah, this is just the color burgundy. I use a select picker from some website there, um, and yeah, this just basically draws each box, and we'll see the UI. This is just the UI. Uh,
Sound
Shout
manager.
out to Louis.
Lewis did the sound
Um,
manager. So basically, the sound manager it takes in a couple sounds that we have over into the file in the file explorer, and it just uses audio input stream to set the clip, get the clip, set the clip. I mean, you just have to instantiate a sound manager object. We instantiated a static one in the game base, I believe, or game an, and we just used it everywhere. It was really easy to use. We set clips, played them. We also had there was also a loop function, so we had main game music, which we did set. It got very annoying during testing, so we shut it off. But we will show it to you during the test. But yeah, we have these 13 files. There is a volume function. Doesn't it doesn't seem to work too well, but yeah, that's basically the sound manager.
and we have special attack, which we discussed in stats. Special defense, discussed in stats. Speed as well. Square root error is just another exception. Stats, we covered it. Here we go with subnode. You
Okay,
want to speak?
so we did cover this a little bit, but there is some stuff I do want to show you. So subnode takes in a game state and a goal node. Goal node is just basically the player character is beaten. And the game state is the current game state. So basically, it builds a neighbor list of the current game state. So the current game state is just like what you are now, so what your current Pokemon health is, how many current Pokemon you have, and same thing for your the player trainer, so the AI and the player. And so whatever moves the AI can currently make, that's all part of the neighbors. Whatever items the AI can currently use, those are all neighbors. Whatever Pokemon the AI can switch to, those are all neighbors. So every single one of those is made into a neighbor, and those are all parsed and rated. So if you go down a little bit, just let me show one little thing. So those are all. So the neighbor list is built. Keep going down. Right. So this is just building the neighbors. I just want to show the rating. So keep going down. Where is it? Not this one. This one, the get estimated costs. So this is where it takes into account the different skill levels. So basically, depending on the skill level, it uses. So if the you'll see the very top one is random, it returns a random number. But as you have more skill, it takes into account more factors, and that's all using Jonathan's awesome Pokemon class and all of his stats and types, and all that was a super big help. All right, you can keep going.
Uh,
Oh, super potions, collectible. It extends collectible item, and that in turn extends asset. So its strength is set to 50. That's just the amount of health uh, it returns to the Pokemon that you use it on. It has an entity in its constructor, so it knows who has it. It has a value, so you can sell it or buy it from the merchant. You can drop it. And when you use it, it uses the sound manager. As you can see, sm dot set file to sm dot play. So if you do use it, it has a sound. You can keep going.
Super rare is just inherited, and I call it switchbox. So I guess you could see why I study programming. My English is not so well. I keep using box for everything. Um, Here, this is just it's just a box to show us all the Pokemons, and it'll show us if they have oh, I see my so because I put int here, it automatically takes it because it's a percentage. It automatically has it at zero. So we'll probably see that it's gonna show. Um, we'll probably see that it's gonna show that they have zero health when they only receive some damage because it has it as an integer here, therefore zero. But this just shows the health and all that as we're battling, and it's a UI, so you could see it visually. Switch listener is just another listener, just like the attack listener. And again, we have Lewis's sound player here, and we have Dan as player trainer, which heavily influenced the ease of this. Um, and then switch mode error, which is just an error if you switch to something that doesn't exist. And tester, I guess we was testing, shows definitely testing work. Tiles, oh, the famous tiles. Yeah, these tiles. The most important thing about these tiles is this class right here, which it basically creates an instance of its child based on what number it finds. If the mapper, so if the mapper finds a W, it just says, "Hey, this is walkable." If it's you, it'll be like, "Hey, this is unwalkable," so you can't basically go through it. It's just for display there. And confrontational is just you could find Pokemons. And type of P is the thing I explained earlier about these letters are just literally just map into these lists of their name. It was just to make it easy. And unwalkable is just a tile, like we spoke earlier. And here's the math for you can't pass through the tile no matter where you are. Um, and let's see, collision from the oh yeah, this is just collision from the top, so it detects collision from everywhere. Walkable is another tile, which you're there's not much to explain in tile. It's you could walk through there, and it'll develop waypoints if they're around. And walkable floor that was never implemented, and wrong type exception, that's just an exception again. And here's the resources, and
Yeah, that's it for now. We'll do a demonstration in a second.
so